exterior angle of a triangle. Last time we talked about the fact that if you had a triangle, the interior angles would add up to 180 degrees. So let's say we had A, B, and C. A plus B plus C would equal 180 degrees. But what about an exterior angle? Let's call this D. What's the relationship between the inside and the outside? So, if we knew that we had a triangle that, for example, this angle B was 75 and C was 30, and we were looking for A, we would say that A equals 180 minus 30 plus 75. And the reason for this would be the steps. And the reason for this would be 180 degrees in a triangle. And what have we done? We've just changed so that we have 180 here, and we've brought the B and the C over to subtract it here because we're looking only for A, so we get rid of it on this side, minus B plus C, and whatever we do on this side, because of the equals, we have to do on the other side, so minus B and C. So A equals 180 minus 30 plus 75. So we have 180 minus 105, and this is 75 degrees. Okay, so A then equals 75 degrees. But what if we were looking for D? Okay, D equals 180 degrees minus 75 degrees. Why? Supplementary angles. Okay, you can see that this here is straight, so these two angles together have to equal 180 degrees because of supplementary. So if we do this subtraction, then we see that 180 minus 75 is 105. Now, 105, didn't we hear 105 before? We did. 105 is the sum of the two angles that were away from the exterior line, so 30 and 75. So that means the two angles that are opposite the angle that has the exterior line end up adding to the one. And it makes sense if you think about it. If we think about A inside the triangle, and we're looking for A, we have A equals 180 minus B plus C. But we can also think about A in terms of the supplementary line. So it would be 180 minus D. Since A equals A, we could say 180 minus B plus C is equal to 180 minus D. If we put all the variables on one side and all the numbers on the other, we end up with 180 minus 180 is equal to negative D plus BC. The 180s go away, so we have 0 is equal to negative D plus B plus C. And so D then we can bring to the other side to get rid of the negative. So what are we going to have? We're going to have D is equal to B plus C. So it shows you that the exterior angle here is equal to the sum of the two interior angles that are opposite from that exterior angle. So let's do an example. If you had a triangle with an exterior, and let's say this was 45 and this was 90, we were looking for A and B. You can find A using your steps and your justifications. You could say A is equal to 180 degrees minus B plus C. Reason, 180 degrees in a triangle. So that's 180 degrees minus 135 degrees is 45 degrees. So A would be 45 degrees. B, you could say that B is 180 degrees minus 45 degrees because of supplementary angles, and that would give you 135 degrees. Or you could say that B equals 90 degrees plus 45 degrees, which is 135 degrees, because of exterior angle of a triangle. Another example you could see is if you had the outside angle, so let's say that this was 150 degrees, and you didn't know A and you didn't know B, and this here was 30 degrees, for example. Okay, you could say in your steps and justifications, A equals 180 minus 150, which is 30 degrees. And the reason for this is supplementary angles. And you could say B is 150 degrees minus 30 degrees, which is 120 degrees, because of exterior angles of a triangle. So you could absolutely still do it using 180 degrees in a triangle now that you found A, but you just want to have as many tools that you can in your toolbox for when you're solving greater complexity problems, and they're going to be ones that are harder than this, so the more things you have, the easier it'll be for you.